from the previous video, we talked about shielding, de-shielding effect, and these are the factors that affect chemical shift, okay, or shielding, de-shielding effect. So we have anisotropic effect, resonance, inductive effect, and orbital effect, right? We're going to look at just some of this, and we're going to focus on the chemical shift of these functional groups. Okay, so I'm gonna so we have talked about IR. If you remember, I divided the whole IR spectrum into 4 regions. If you remember that, right? I'm gonna do the same because you're familiar with that. I'm gonna do the same with carbon and MR. Let's take a look. So I'm drawing the line at 50 ppm, right? 100 ppm, 150. So we have four regions. So we have an sp3 carbon usually show up right here. sp3 carbon with the electronegative atom. sp2 carbon show up downfield, right? So regular sp2 and then sp2 carbon with an electronegative atom or something along that line. We'll get there. Okay. All right. Now, the regular sp3 carbon, or I call it hydrocarbon, it's actually hydrocarbon, like nothing's on it, right? Usually around 20, but I mean, it can range from 5 ppm up to 40 ppm. It depends on what's on it or what it bonds to, right? But it's about 20. Just I give you a range, right? And the quaternary carbon, which means this carbon bond to 4 more carbons, is more de-shielded to the left side, right? Show up on the left side, then tertiary carbon, then secondary carbon, and just primary carbon. Okay, primary carbon is really upfield. Yeah, real. Anyway, the alpha carbon, which means the carbon one position of the functional group. So we have functional group, one position of it, alpha carbon, functional group, alpha carbon, functional group, and alpha carbon are more de-shielded than hydrocarbon. Okay, so I give you a range again, so 20 to 50, but it's around up here, maybe 30 or 40, but yeah, but I mean, they're close, they overlap as well. Hard to tell between these two. All right, but basically my point is regular carbon, sp3 carbon show up on the first region about less than 50, about 20, 30, 40, about that. All right, all right. I give you some number just for like do not memorize this, but I give you an example so you have a reference. A regular carbon CH3 7.3 ppm, okay. A CH2 15.9 ppm, so more de-shielded. So we have regular carbon primary go to up to the secondary, so we have 2 more carbon next to it. If a carbon have 3 more carbons bond to it, even more de-shielded 25. Quaternary carbon bond to 4 more carbon 27. Okay, so we have that trend. All right, let's do this. So if you get what I mentioned earlier, which peak is which signal, okay, I mean which carbon is on which signal. Number 1, so we have a carbonyl carbon, haven't talked about it yet, but we have a CH3 regular carbon right there, and if you remember, it's going to be on about 20, 30, 40, less than 50 on the region number 1. Okay, so that this signal right here, that's number 1. The other one, so this carbonyl carbon is ketone aldehyde. We'll get that. Is a region, the last region, so over 200. Okay, so this one is clear. All right, try one more time. So there are 4 carbons. We have 4 carbons here. Can you match this carbon to the signal? Well, pause the video, try on your own, and then check with me. Okay, so let's say what we have right here. So I'm going to draw the line real quick. So that's the region number 1. So that's 50 ppm. Okay, up to 50 ppm. All right, what we get here? Carbon number 1 and number 3. These are regular carbon, but 1 and 3, if you realize that, those are alpha carbon. Okay, number 4, just regular hydrocarbon. So I'm going to guess that the regular carbon hydrocarbon is the most shielded and the most upfield, right there. All right. Now, 1 and 3, both are alpha carbon, so probably these 2. Okay, so what's the tiebreaker? Well, carbon 3 is a CH2. Carbon 1 is a CH3. If you remember that trend, right? CH2 is more de-shielded than CH3. It's got that trend. So I'm going to guess that the carbon number 3 is right there and carbon number 1 is down there. Okay, and the last one over 200, that's carbonyl. Aldehyde ketone is above 200. We'll talk about this in detail later. All right, that's region number 1. Now move on to region number 2.